Before we start looking at our different sources of energy, let's take a look at how electricity is produced. It generally follows the same basic scheme no matter what your source is. So the first thing that happens is we have something or some source of energy that generates heat, enough heat to heat water. The water starts to boil, which produces steam. The steam turns blades in a turbine that's connected to a generator, which generates electricity. So in this particular diagram, here we have coal, which is our source of energy. The coal is burned to produce heat. The heat burns the water, or sorry, it doesn't burn the water, it boils the water, which produces the steam. The steam moves through these pipes, turns the blades in the turbine, which turns the generator and sends it out to the power grid. What you see coming out a coal burning power plant is you have the gases that are given off as the coal is burned. So this is what happens whenever you are burning something, whether it's coal, oil, or some sort of biofuel. If we look at electricity production in North Carolina, as you see on the right side there, we have nuclear power. Sharon Harris is the closest power plant. We have coal burning power plants. Here's a picture of one that's in Asheville. We have hydropower as well. Fontana Dam is in the western part of the state. But for producing electricity, average efficiency is about 33%. And remember, efficiency is what percentage of the energy is actually converted to useful work compared to what is lost as heat. So coal is about 30 to 40% efficient, meaning we're losing anywhere from 60 to 70% as heat. Nuclear power is 25% efficient. Electricity is produced on demand. We don't store it. So if everyone is running all their appliances, their heaters, or their air conditioning units or whatever at the same time, then our power plants are going to have a higher output. In the middle of the night, when everyone's asleep, our power plants are going to be producing less. So let's say that you have a lot of people that are all using a lot of electricity, and we're getting close to capacity at a power plant, then they're going to build more power plants. So plants are built to accommodate the peak demands, not the average consumption levels. So as we said, energy efficiency is when we compare the energy that's input that actually does useful work compared to what is lost. If we're looking at life cycle costs, we're looking initial costs, so that's actually the construction of the power plant, finding the land, clearing it, and then also looking at lifetime operating costs. How much does it cost to run the plant? How much does it cost to pay to workers? If we're looking at appliances or devices, the three least energy efficient are the incandescent light bulb. If you've ever touched one, you know that it is giving off a large amount of heat. Internal combustion engines, those are gasoline burning engines in your cars. And nuclear power plants, if you're using it to produce electricity for space heating, they're not inefficient when you look at producing electricity for other needs. So the first thing that we're going to look at are our non-renewable energy resources. Those are our fossil fuels. We know that solar energy makes up 99% of all energy that's used to heat the earth. It's the commercial energy that we're looking at, the remaining 1%, and most of that does come from extracting and burning our non-renewable resources. Of that 1% of energy that is commercial energy, 90% of that comes from non-renewables, 85% is fossil fuel, about 5% is nuclear. In our less economically developed countries, their main source of energy is biomass, so mainly like fuel wood or charcoal. So our non-renewables, we're really looking at our MEDCs in our industrial areas. So if we look at global energy use and the percentages, oil is our #1 energy source, then coal and natural gas. So our three fossil fuels top that list. Then we have uranium. Our renewables, biomass, hydro, wind, solar, wave energy, all of those are a very small percentage compared to our non-renewable. It's probably no surprise that the U.S. is the world's largest energy user. If we look at the history of energy use, in the Industrial Revolution, that's when we first started our dependence on coal, moving to non-renewables. In 1915, we started using oil, and it wasn't until the 1950s that our use of oil overtook that of coal. 1968, the percentage that we use for hydroelectric overtook wood, and nuclear overtook wood and hydro in 1973. Looking just at petroleum or crude oil, when we pull it from the ground, it's a thick liquid made mainly of hydrocarbons. It does have smaller amounts of sulfur, oxygen, and nitrogen. When we burn it, that sulfur, that nitrogen is released into the air. But petroleum is produced when dead organic matter from plants and animals that lived millions of years ago have decomposed under high temperature and high pressure. It gets trapped in the pores and cracks and rocks underground, and so we have to drill down into those cracks to get it out. It does have a high net energy yield. However, when we pump the oil from the ground, usually only about 35% of the oil in that well is recovered. The advantages of using oil is that it's relatively cheap. It's easy to transport it. We've got pipelines, oil tankers. It's versatile. It has a lot of uses. And drilling only causes moderate damage to the land. It's not going to cause much surface damage. Now, there are drawbacks to using oil. One of the big ones are the emissions, the carbon dioxide that is put into the air when we burn oil. Most of the reserves, or the areas where we get oil, are in areas where consumption is low. So then it has to be transported to other areas, which takes energy. Tanker spills, which are rare when they do occur, do create a large problem for that particular area. Now, the majority of oil in the ocean actually comes from runoff from the land, mainly from cars. But an oil spill can cause a lot of damage to the ecosystem where it occurs. The pipeline construction and the oil spills themselves can also cause habitat destruction. When we drill for oil, if you look in these two pictures, you can see two different types of drills. We've got one on land and we have one out in the water. A lot of times oil can be found on the continental shelf. OPEC, or the Organization of Petroleum Exporting Countries, control about 67% of the world's crude oil reserves. So of the OPEC countries, 64% of those are in the Middle East, so that's mainly Saudi Arabia. We do get oil from Latin America, mainly Venezuela, a little bit in Africa, Soviet Union, or what is now Russia and the surrounding countries, Asia, a small percent in the U.S. and in Europe. We use about 30% of crude oil extracted worldwide each year. We import over half of what we use. At the current usage rates, that's assuming that population doesn't grow and people aren't using oil at a higher rate. It only lasts about 53 more years. Now, we do think that there are undiscovered reserves out there that might add an additional 20 to 30 years. But many people use oil and don't spend a lot of time concerned about alternatives because of the artificially low prices. It is affordable to fill your car with gas, to drive to where you're going to go on a day-to-day basis. It's not so expensive that you can't afford to pay for your gas. Natural gas is another of our non-renewables. It's made mainly of methane, but also has other hydrocarbons like ethane, propane, and butane. Most natural gas is found above the reserves of crude oil. So when they drill down to get to the oil, they actually go through natural gas. Propane and butane can be liquefied and removed as what we call liquefied petroleum gas, or LPG. The methane, which remains in the gas form, is usually dried out to remove some of the water vapor. They remove some of the other impurities and pump it through pipelines. Natural gas is cleaner burning than either coal or oil. It has a higher energy content and a higher net energy yield. So it is the most efficient of our three fossil fuels. Russia and Kazakhstan have about 42% of the world's natural gas reserves. We only have about 3%. Now, we think we've got about 125 years left, depending on how much gas we use. Now, ideally, we'll use more natural gas and cut back on oil and coal because it is more efficient, and the money saved can be put towards researching some of our renewables. It's cleaner burning, lower carbon dioxide emissions. So it is better than using coal or oil for our energy needs. You can see from this diagram of when we dig down for oil, usually you're going to go through a pocket of natural gas. If you've ever seen one of the rigs out in the continental shelf, sometimes you'll see them actually burning off the natural gas to get to the oil. The last of our fossil fuels, and it's the dirtiest, is coal. It is mostly combustible carbon. It does have sulfur and mercury and even radioactive materials that are all released when it's burned. Coal provides about 22% of our commercial energy and 62% of the world's electricity. It's our most abundant fossil fuel. The supplies could last anywhere from 225 to 900 years. The U.S. and Russia have the largest reserves. China has about 11%. It's not very efficient. We do lose a lot of heat when we use coal as a power source. If we look at the different types of coal, depending on how deep it's buried, you're going to have different forms. So closest to the surface, we have peat, which is partially decayed organic material. It can be burned, but it's going to have a very low heat content. Lignite is what we find in most of our coal reserves. It's a softer brownish black coal. It also has a low carbon content, so it takes a lot of it to produce energy. Bituminous, a little more carbon content than lignite or peat, but still it's not our most efficient form. It's called soft coal. Anthracite's the most desirable type. It has to be pressurized, and it's made about 98% of carbon. It's less common, but it does have the most heat content when burned. Coal has a very high environmental impact. Mining has a severe impact to the surface. We know that when we burn carbon, we have high carbon dioxide emissions, in addition to the sulfur and mercury and radioactive particles that are found as well. The sulfur that enters the atmosphere can combine with water vapor to create sulfuric acid, which is a major cause of acid rain. We do have scrubbers on the smokestacks that remove some of the sulfur. What they do is the emissions run through limestone, and limestone can filter out some of those impurities. Nuclear is the last of our non-renewables. We have about 109 licensed power reactors in the U.S., 400 total in the world, and it produces about 20% of the world's energy. The first type of reactor is called a breeder reactor, and they take uranium-238 and convert it into plutonium, which can be used as a fuel. Uranium-235 can be used directly as a fuel in a nuclear fission chain reactor. We'll take a closer look in class at how nuclear fission reactors work. But just like our other sources of energy, you're using the heat produced to generate steam to turn a turbine to generate electricity. Advantages to nuclear: we've got plenty of uranium. Even though it's a non-renewable, we've got a very large fuel supply. Low environmental impact. What you see is water vapor coming out of the towers. It is expensive and has a low net energy yield. And when there are accidents, even though they're rare, can create catastrophic problems. We don't have a solution for long-term storage of radioactive waste, and eventually our nuclear reactors have to be decommissioned. Our current U.S. reactors will all have to be retired by 2030.